Okay, question 12. This one's not too bad. I'm going to use, first of all, Newton's second law for m. That's going to be just to the right. The only force acting to the right is T, so T is just going to equal 2a. Let's call that equation 1. I'm now going to do Newton's second law for W in a downwards direction. So this is assuming that the acceleration of A is to the right, of m is to the right, and the acceleration of this one is downwards, which is fairly obvious. So for W, acting downwards, we've got 0.1 g, and that's got T acting against it, and that's going to equal 0.1 a. So that's 2. So if I add the two together, the t's cancel. On the left-hand side, I've got 0.1 g. On the right-hand side, I've got 2.1 a. So a is just going to be 0.1 g divided by 2.1, which comes out as a fraction as 7/15 or 0.46 recurring. And if I just use this first equation, I know that T is equal to 2a, which in other words is just going to be 14/15 or 0.933 newtons. Okay, so that's the first bit. That was finding the tension. That's quite easy. That's part A. Part B says that you've got you want to find the speed of W immediately before m reaches the pulley. In other words, when both of them have travelled 0.6 meters. Well, the system was released from rest, so U was 0. B is what we're looking for. A is, as I've said, 7/15. The distance travelled by both is 0.6, so we're just going to use V squared equals U squared plus 2AS to find V. U is 0, so literally it's just 2 times that 7/15 multiplied by 0.6. Now that just comes out as 0.56, so V is just the square root of 0.56, which comes out as 0.748 meters per second.